For that, I wish you good morning to all of you.
Good morning, ma'am.
Good morning, all of you. Thank you. So far, do you find any problem regarding this chapter?
No, ma'am.
Okay, so let's start now. So we'll go equation by equation. There are three equations of motions. We will do one by one. Do start with it.
Equation of vertical motion under the influence of G. Let a body be thrown vertically downward with initial velocity u. Let the final velocity of the body after time t be v. Let h be the height, vertical distance covered by the body, and g be the acceleration due to gravity. Then the
Fine.
equation of motion r.
Just wait, bit. Just wait. Thank you.
Okay.
Look over here. Now this is the body. It's been thrown down. Okay. This is the body which is thrown down. So what is the velocity? U is equal to 0. Agree? Initial velocity is 0 because I'm holding the ball, right? Hello?
Yes, ma'am.
Yes? Okay. Then it gets some b velocity, some xyz, any velocity, 2 meter per second, 2 kilometer per second. Some of the velocity it gains. What is the height by which it travels? It's h. How much time does it take? T. You got it now? This is what we have to understand. So you got the idea? What are we doing?
Yes, ma'am.
Fine. Now we will see
Then,
the equations. Yes, then the equations.
then the equation of motion r. V is equal to u plus gt. H is equal to ut plus half gt square. V square is equal to u square plus 2gh.
Fine. Now we know V is equal to U plus AT. Agree? Agree?
Yes, ma'am. Yes, ma'am.
Instead of A, what we have put?
G.
G. Why? Because
G.
it is acceleration due to gravity. This you understood?
Yes, ma'am.
Other one is S is equal to UT plus half AT square. You agree?
Yes, ma'am.
Where S is the distance, right? S is the distance. And what is H?
What is
H is the
that?
height. Hello?
Yes, ma'am.
S is the distance. Someone's mic is on with, and H is the height. Got it? That is difference. UT remains UT, half. Instead of A, what have we put? G. That's the difference. Okay? Now you understood?
Yes, ma'am.
Now we come to the third equation. V square is equal to U square plus 2AS. V square remains V square, U square remains U square. Instead of A, we have put G. Instead of S, we have put H. Got the difference? Hello? Did you find the difference in the equation?
Yes, ma'am.
That's all we have to do. The basic structure of the equation remains the same, but height, the distance becomes the height, and the acceleration, that is A, becomes the acceleration due to gravity, that is G. That's all. That's all we have to do. And the rest remains the same. Is it clear?
Yes, ma'am.
These are the three equations of motion. And this is the motion due to gravity. Remember that. Let's come to, see, remember, this is the equation of motion. Now we will see how the body is dropping. Let's see.
When a body is dropped freely, the equation of motion r. V is equals to gt. H is equal to half GT square. V square is equal to U is equal to 2GH.
Do you know how we got this equation? Can anyone tell me how we got this equation? What is the
No,
formula, beta? Okay, just be with me. What is the formula? V is equal to what we got earlier. What is the first equation of motion? V is equal to,
V square plus GT.
say, U plus GT. Yes or no, beta?
Yes, ma'am.
Yes. Okay. Now body is dropped freely. That means the body is over here. So what is, I'm holding it. So what is U? I'm holding the ball. So what is the initial velocity? It is
Zero.
at the state of rest, isn't it? It is a state of rest. It's not moving. So U becomes zero, right? Hello. Do you get me?
Yes, ma'am.
I'm holding the ball. So there's no motion of the ball. It is at the rest. It's not moving. So U is zero, right? And then I leave it. Then it comes down due to gravity. Yes or no?
Yes, ma'am.
Fine. So you agree with me that U is equal to zero?
Yes.
So what happens? What I will do? Please, someone's mic is on. P is equal to 0 plus GT. P is equal to GT. This is what we got. Agree? Hello.
Yes,
You agree
ma'am.
with the equation? Got it? How we got V is equal to GT? In place of U, we put 0 because the initial velocity, I'm holding the ball. So the ball is at rest. It is not moving. So initial velocity has to be 0. So we wrote V is equal to 0 plus GT, and so V becomes GT. Any problem? Any problem with that? Now you came to know how we got V is equal to GT? Hello? Hello? Boys, please answer. Can you hear me? Hello? Can you hear me better? Boys, can you hear me? Yeah, can you hear me? So please answer me whether you have understood this equation. Hello? Okay. We start with the next equation. H is equal to half GT square. Can you tell me how we got this? S is equal to UT plus half AT square, right? So what we have done over here right now, S is equal to 0 into T plus, sorry, it is not S, it is H. H is equal to 0 into T plus half GT square, right? So H becomes 0 plus half GT square. So H becomes half GT square. Understood? This is how you got the second equation. Any problem? Boys, any problem? Hello? Raza, Saheem, can you hear me? Sona ma'am? Sona ma'am? Shona ma'am, can you check? Boys, can you hear me?
Yes, ma'am.
I'm not getting any reply from the boys. Can they hear me, ma'am?
I can hear you, ma'am. So they can also.
Okay. I don't know because I'm keeping on asking them, but I'm getting faint reply. It's not loud.
Okay. Yeah. Actually, I was busy somewhere, so I didn't reply. Now I can
Okay,
hear you properly.
just can you ask them to be on the I mean to be
Okay.
prompt in the meet if
Okay.
possible.
Boys, are you there? Anyone, please reply. Are you there or getting voice of ma'am? So we can continue. Just say yes or no. If you can't say, please message us in chat box that you can hear us. Okay. Boys.
Are they there, ma'am? Are they there?
Yes, 9 boys are there.
Okay.
Sorry, six
Okay,
boys
fine.
are there, but they are not replying.
Okay. So Raza, can you hear me? Saheem? Hello? Yeah, please start reading, beta. Now we come to b square is equal to u square plus 2gh. We know that u square is 0, so v square is equal to 0 plus 2gh. So v square is equal to 2gh. This is what we got. So I hope now you know how we derived all the equations pertaining to gravitation. Remember that. So we are working on gravitation now and not on acceleration. So you have to be very clear about it. Okay. Let's start with the third factor, beta. Yes, start. Start reading. Yes, boys, start reading. Start reading, please. Should I continue? Raza, can you hear me? Any of you, please start reading. Hello? And if you can't hear me, hello? Yes, please start reading, beta. Salman, if it's you, start reading. Now, in the third case, the body is down, it is thrown up. Understood? So, what will happen? Let's see. V is equal to, we know that V is equal to U plus GT, right? But when the body is coming down, that is V is equal to U plus GT. But when I'm throwing the body up, the acceleration due to gravity becomes negative because it is going up. So what it will be? V is equal to U, the G will become minus. So U minus GT. This is the first equation of motion due to gravity. So because I'm pushing it up, I'm throwing it up, so it's working against the gravity, so G becomes minus. Next one, H is equal to ut plus half gt square. Agree? Right? Here is the initial motion because I'm throwing up, so u has to be there. So what it will become? H is equal to ut remains ut plus half g becomes minus because it is going up. T square remains t square. So the equation becomes ut minus half gt square. This is the second equation that we get. The third equation, v square is equal to u square plus 2gh. Remember, v square is equal to u square plus 2 into minus g h. V square is equal to u square plus 2 into minus g becomes minus 2gh. So you got the third equation. I hope you have understood with this all how we have derived the equation of motions due to gravity. Any problem, beta?
No, ma'am.
Boys, any problem? Okay. Raza, were you able to hear me? I mean, I have called you so many times. Were you able to hear me?
My grandmother called me.
So you were not there.
Yeah, ma'am.
Okay. Now, how to calculate the value of G? Let's do. Start.
Calculation of value of G. We know that the accepted value of G is
Capital
6.6.
G beta. See, what we are finding out is the value of small g.
Yeah,
What we know the value of capital G.
the
So you have to
accepted
say
value
capital
of
G,
capital
capital
G
M. Like, yes,
6.673 into 10 raised to minus 11 Newton meter square kilogram
per kilogram. Per
per,
kilogram square.
per kilogram square. The mass of Earth mass is equal to 6 into 10 raised to 24 kilogram. Therefore, by using expression G is
No,
equal
the
to
radius of Earth you have to say.
okay, radius of Earth is equal to 6.4 into 10 raised to 6 meter.
So we have been
Therefore,
given all the values, so it's easy to find out the value of small g, right? We have got the three values. The G, capital G, we have got capital M, and we have got the radius. So when we know all the three, we can find out the values of small g. So what is it? Let's see.
therefore, by using expression G is equals to capital G M divided by radius square, the value of G can be calculated.
Continue.
Therefore, after substituting the value of G, capital M, and R in the expression of G, we get G is equals to 6.673 into 10 raised to minus 11 Newton meter square per kilogram square into 6 into 10 raised to 24 kilogram divided by 6.4 into 10 raised to 6 meter square.
Meter
G is equals to
whole
9
square.
point
Yeah, whole square.
whole square.
So when we place all the values, we get G is equal to what is
9
small g
point
by the way? Yeah, what is small g by the way?
acceleration due to gravity.
What is small g? Yeah,
Acceleration due
exactly. It is acceleration due to gravity. Yes. Then
to motion of an object under the influence of gravitational force of Earth. The expression for G is written as G is equals to G capital G M R square divided by R square.
this is yeah. So this is what we have to remember. This is the formula that you got. Acceleration due to gravity, and that is 9.8 meter per second square is equal to k is equal to constant. This is what we have to carry on further.
Means
It never changes. Yes, beta?
what is K?
Constant. That's why I've put it as equal to. It's a whenever we want to write. Remember, uh, uh, the proportional A is proportional to F. If I write that, okay. But when I
Yes,
put it A is equal to, then I have to write K and then I have to write F. You understand?
yes, ma'am.
So whenever I'm equating the proportional sign, I have to put a constant sign, and that constant sign always generally we take it as K.
Okay.
Understood?
Yeah.
So that remains constant. So you have to remember this formula. So all the formulas I have already derived, I've already expressed, I've already conveyed how we got the new equations. We know the three equations of motions, how we derived it due to the with the help of the graph. Remember that in the last chapter. And the same thing when we are doing with the gravitational point of view, how it has differed, how it has changed, what are the factors which made it change, how plus became minus, everything I showed you. I think I, I hope the things are quite clear with all of you.
Yes, ma'am.
And this never changes. 9.8 meter per second square is the constant, universal constant. It is what it is, universal constant. It never changes. Sometimes due to make numericals, to solve the numericals in an easy manner, we take this 9.8 meter second per second square as 10 meter per second square. Sometimes it will be given to you in bracket. You can take g is equal to, because when we do approximation, obviously you know that 9.8, this is more than 5, is it? Isn't it? 9.8, that means the 8 is more than 5, so we can take it as well. 10, remember? So 9.8 and 10 is almost similar if I take approximation. Sometimes for making numericals easy, we take g is equal to 10. You understand? Only
Yes,
that time when we are asked or we are told. Otherwise, it remains as 9.8 meter per second. Any problem regarding this slide? Any problem? All of you have understood better? Rest of the
yes, ma'am.
boys, you can stop me anywhere. You can stop me in between better. Okay? The same thing we are doing again. It's revision again. Same thing to find out the value of small g. Okay? Yes, start better.
Yes, ma'am. Acceleration due to gravity on the Earth is calculated as follows. Mass of the Earth is equal to 6 into 10 raised to 24 kilogram. Radius of the Earth is equal to 6.4 into 10 raised to 6 meter. Gravitational constant is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Small g is equal to capital G m divided by r square. Substituting the values, we get g is equals to 9.8 meter per second square. For simplified calculation, we can take g as 10 meter per second square.
So you recall what I said just now?
Means,
Do you remember?
yeah, ma'am.
Just now
We
I
can
typed
substitute
said.
between
Yeah. So in this
9.8.
slide we got this thing as an extra. In the earlier slide this was not mentioned. Remember? You got my
Yes,
point what I'm saying? And so we are going to learn, something different, something more. So that's the reason that I've taken so many slides for one topic. Okay, let's start.
we variation of acceleration due to gravity g. Acceleration due to gravity decrease with altitude. G is equals to capital G m divided by r square. G raised
Dash,
to
G
G
dash.
G dash is equal to G raised to G
No,
dash is
G.
equal to G m divided by r plus s square.
You got my point? What is it? They are
Yeah.
finding the acceleration. What is the change in acceleration due to gravity G? There has to be, isn't it? It's a change in acceleration due to gravity G. What it
Yeah.
is? We know this formula. Do we know this formula?
Yeah, ma'am.
This is just acceleration due to gravity. But what is given there? It decreases with altitude. That means when we push it up, when we throw it up, more it goes, the acceleration due to gravity is less. Do you remember? For example, this is the ball. I've thrown it up. Here it reaches. Now, my question to you, the acceleration due to gravity will be more here or will be more here? Where will the acceleration of gravity? A or B? Can you tell me?
B.
B. Exactly. Because it is near the earth. This is the earth. That means as the altitude or as the height increases, the acceleration due to gravity decreases. As simple as that. What do you say?
Yeah, ma'am.
Isn't it? The pull is less when we go high. The pull is more when we come down, right?
Yeah.
For example, I give a very common example. When you were young, you would slide. So this is the slide. This is the slide. Right? Simple? Yes or no? So you're over here. You're sliding. The force is more here or force is more here? Where's the force? The more force of, go, and then you somewhere land over here. Remember, with the force you somewhere land over here in the sand. You get the force more at B or force more at B when you're sliding down the slide. Where do you get the maximum force?
B.
The maximum pull. Exactly B. And then you cannot control yourself, so somewhere you land here with a force. Isn't it? But when you're sliding from here, you're sliding very slowly. But then it becomes very fast over here. Do you agree with me?
Yes, ma'am.
So what is it? It is just the opposite. So this G is equal to Gm upon R square is just acceleration due to gravity. But over here, when we are adding the height to it, see, can you see here? We are adding the height with the radius. So it decreases. So as we go away from the Earth, the acceleration due to gravity decreases. Is it clear? Is it clear?
Yes, ma'am.
Because this is R. See what you can see over here. So look at the picture what I'm drawing. This is the radius of the Earth. The acceleration due to gravity will be more. But when I go away, I leave the Earth and go in the space. Do you think we will get the pull of the gravity that much as we are getting on the Earth?
No.
That's exactly, and this will be H. So we are adding H over here. You got my point?
Yes, ma'am.
Fine. Now we are through with the acceleration due to gravity. Now we are coming to a new topic as what exactly is mass and how does it differ from weight? Very small hint I'm giving you before I start or before I uh, define. I just want to tell you mass remains the same. Please put that in your mind forever. If you're going to take up science throughout your life, remember all these small points. Very important it is that mass of an object remains the same whether it is on the earth or it is on the moon, it is in the space, anywhere in the universe or anywhere in the world, it remains the same. But when we talk about weight, what works over there? Gravity. You got my point? Mass is minus gravity, weight is plus gravity. That is the difference. You understood?
No, ma'am.
For example, mass, if I talk about a mass of an object, say it is 2 kilogram, right?
Okay, ma'am.
Kilo, 2 kilogram. So that mass, if I say, okay, mass on the earth, it is 2 kilogram. Then I take it to the moon. Mass on the moon, 2 kilogram. Mass on any other XYZ planet, it will remain 2 kilogram. But when I talk about weight, it will change. Because at that time, we are working it with the force of gravity. Mass is not working with force of gravity. Now, did you understand this?
Yes, ma'am.
That's the difference. So,
What the
the
difference?
basic difference I wanted to this is the basic difference I wanted to add is the mass is without gravity and weight is with gravity. We are going to explain more. This much did you understand or not?
Yes, ma'am.
Mass is without gravity and weight is with gravity. That is the only difference. You understood?
Okay,
Now
ma'am.
let's see how we do that. So here on the left hand side, you can see you have put object. See, this is the object A. Okay, and you have put the weight over here. What we'll say, mass of the body is equal to 60 gram. 50 plus 10 is 60 gram, right? And let's see. What is mass?
Yes, ma'am. Mass. The mass of a body is the measure of its inertia. If the
Inertia.
inertia, if the mass of a body is more, its inertia is more. The mass of a body is constant and does not change from place to place. The SI unit of mass is kilogram.
Just now what I had said, the mass of a body is constant. You agree now? I told you, if you take it on the moon, if you take it in the space, if you take it on the earth, you take it anywhere on the world, anywhere on the earth, it remains the same. And what it is written does not change from place to place. So this is confirmed.
Yes,
And what is the unit of mass?
kilogram.
Kilogram. That is also confirmed. Okay. Let's see what is weight. I will give you
The-
the this inertia. I'm not going to add up this inertia right now. I will talk about the inertia later when you understand everything. Okay.
Yes, ma'am.
See what is weight.
Weight. The weight of a body is the force with which the earth attracts the body. The force with which a body is attracted by the earth depends on its mass m and acceleration due to gravity g. Force is equals to mass into gravity. Since
You
weight
know
of a
that, right?
body, yeah,
What is actually force is equal to ma. Right? This is what we had learned. Then this a becomes g. This is what we have learned now. Earlier, what we had learned, force is equal to mass into acceleration. Remember when we're doing the equation of force or the motion? Remember? So force is equal to mass into acceleration. This is what we had learned. But now what we are doing, instead of acceleration, we are writing gravity. That is g. So force is equal to mg. Right?
yeah.
Okay. Fine.
Since the weight of a body is the force with which the earth attracts the body, weight is equals to mass into acceleration due to gravity.
That is so instead of force, what we have put,
Weight.
what we will say, F is equal to, agree,
Yes,
is equal to mg. Agree?
yes, ma'am.
Next.
Since since g at a place is constant, WAM, the weight of a body changes from place to place. The SI unit of weight is the same as force, Newton.
So we got mass, that unit is kg. They got the difference, and weight, the unit is Newton. That is the difference. You got it now? Because weight has got gravitational constant added to it, it gets converted to Newton because it's a force, whereas mass is not a force. Mass is the exact amount of the body. You got it? You got the difference now? Weight
Yes,
is
ma'am.
a force. Weight is a force where the gravitational force is acted on it, and hence the Newton becomes the unit. Whereas mass is not having any force applied on it, so it remains kilogram. Got my? Actually, we say no weight is equal to kilogram, but actually that is mass. Got my point? Weight is always measured in Newton. Mass is
Yes,
always measured in kilogram. Do you get the difference?
yes, ma'am.
Okay, fine. So I think this time is up. Please do the revision accordingly, and I wish that all of you will do every day's revision because it is important. It is very important because you will tend to forget if you don't revise. So whatever uploaded video you get, it will hardly take better 10 minutes because you already know it. It's just for the revision sake you have to go through it. It will take hardly 10 minutes to revise. Will you do that?
Yes, ma'am.
So the video that you get today itself, uploaded video, and today is your exam, science exam. I hope you know that. Okay? So do well in the exam and make me happy. All the best.
Thank you, ma'am.
Bye, beta. Bye, all of you.